Hello students, welcome to the Smart Teaching Zone YouTube channel. Today we are going to study a topic of integration which is known as integration by parts. So here we are going to see some concept regarding this, and then we will be solving 2 to 3 questions based on this concept. Okay, so let's get started. Suppose a student, we have a integration, we have to do integration of two functions, suppose that is fx and gx, and we have to integrate both of them. Let's suppose this is our u function and this is v function, and we have to integrate both of them. Then the by part rule says that, what is the rule to integrate this function? That if there is a function u into v which has to be integrated, then it will be equal to u will be left as it is, and we will integrate v part first, then minus, then there will be derivative of the u function into integration of the second function as it is, which we have done earlier, and then whole integration. This is the formula regarding by parts to integrate the function. Now here question arises, what is u and what is v? This u is, students, the first function which we have to choose. I will get into it just a little bit later, and the v is the second function. Again we will choose it from a formula which is known as Eilert rule, Eilert principle. Here the I stands for inverse trigonometric function, ITF, inverse trigonometric function. L stands for logarithmic functions like log x, log 2x, etc. A stands for algebraic functions. Algebraic functions may contain like constants like half, 1, minus 1, minus half, minus 5, etc. Or linear function like y equals to ax plus b. Quadratic functions, basically any polynomial can be considered as algebraic function. Then there is trigonometric functions which are sin x, cos x, tan x, etc. Like sin, cos, tan, cot, secant, cosec, whatever angle involved with it. Okay, and then the last one is the exponential function. This exponential function can be natural exponential like e to the power x, e to the power 2x, or a to the power x, a to the power 5x, etc., where a is a positive integer greater than 0. Okay, so this is the way preference order in which you will take the first function. Suppose there are two functions, we have to integrate. Suppose this x square log x, this is the function which we have been asked to integrate. So first of all we have to choose which function is u and which function is v. So the u function will be the first function and v function will be the second function, and accordingly we will apply the formula. So here we can see that x square is a quadratic function, and quadratic is what? Algebraic, and log x is log function. So log comes before the algebraic function, that's why we will choose log function as the first function and x square as the second function, because it is algebraic function. Now according to which this will be u and this will be v. Now we will apply the by parts formula to integrate it. Okay, now let's take a question based on the Eilert formula or by part formula. Okay, so here we have a question, x into sin x, which we have to integrate this function x into sin x, and since it contains two functions, and as we know that this x is linear function, so it will be considered as algebraic, है ना? This will be algebraic, and this sin x is nothing but trigonometric function. Okay, so according to Eilert principle, which come first? Algebraic come first, then trigonometric. So this algebraic function will be considered as first function, and the trigonometric function can be considered as second function. Now according to which we will integrate. So what was the by parts formula? The first function will be left as it is, integration of second function minus derivative of first function, which is derivative of x, and the integration of second function as we did earlier, sin x dx, and the whole integration on this part. Okay, so what will it become? It will become like x integration of sin x is nothing but minus cos x then minus the derivative of x with respect to x is 1, sin x integration is again minus cos x into dx. Okay, so by this when we will multiply it, it will become minus x cos x. We can take minus out of the integration because it is constant, so it will become like plus integration of cos x into dx. Okay, so we can see that this become minus x cos x, and the integration of cos x is nothing but sin x. Okay, sin x plus some arbitrary constant c. So this will be our solution. Okay student, let's take another example, which is x square into log x. So we have to integrate this function. Again, if we will use the Euler principle, what does this say? That the algebraic function will come later than log function. The order of preference is log function will come first, then algebraic function. So here we have to consider log function as first function and x square as second function, according to which now we will apply by parts formula. So using by parts, what happen? Our integration will become, we have to leave the first function as it is, so log x as it is, integration of second function. Okay, then minus derivative of the first function which we have left earlier as it is, then integration of the second function same to same which we did earlier, and then the integration of whole second part. Okay, this is the by parts. Now the log x is left as it is, so it will be remain as it, and the integration of x square will be x to the power 2 plus 1 over 2 plus 1, using the formula x to the power n dx is equals to x to the power n plus 1 over n plus 1. Okay, then there is minus sign. The derivative of log x is 1 by x. The derivative of x square will again become x to the power 2 plus 1 over 2 plus 1. Then the sign of the integration will come. Okay, so this has become nothing but x to the power 3 over 3 log x minus, since this is 1 by x and this will become x to the power 3 divided by 3, we can cancel out x to the power 3 using x and leave it as x square. Okay, so again this will become x square divided by 3 log x minus, we can take 1 by 3 constant out of the integration, so the whole integration will become nothing but x square into dx. Okay, so we can write it as x cube divided by 3 log x minus 1 by 3, and the integration of x square will be x to the power again 2 plus 1 over 2 plus 1. So 2 plus 1 is 3 divided by 3 plus c. So our final answer will be x to the power 3 divided by 3 log x minus x to the power 3 divided by 9 plus c. This will be our final answer. Okay, I hope you understand the procedure and the formula used by us. Okay, now let's take another example. This is x times tan inverse x into dx. We have to integrate it using the by parts formula. Okay, by part rule, sorry. So let's look at the Euler principle. So what does the Euler principle says? That the ITF function will always come first. This I stand for inverse trigonometric function, inverse trigo function, and since we know that tan inverse x is inverse trigonometric function, so we have to consider it first function. Whatever the second function is, it doesn't matter. Whenever the ITF will come, that will be considered as the first function because it is first in the preference table. Okay, now the x is algebraic, so again it will be second function. Now let's integrate it using the by parts formula. So using by parts, we can write it, we have to leave the first function as it is, so tan inverse x will be as it is into integration of the first function, so it will be x dx minus, it will there will be derivative of first function which we have left earlier as it is, so the derivative of first function will be tan inverse x. Okay, now we have to integrate the second function again as it is, x dx, as we did earlier. Okay, and now the integration of the whole second part. This is the by parts. Okay, so what will it become? It will become tan inverse x into x square over 2. Okay, since it is x, so we have to use the formula x to the power n plus 1 over n plus 1 minus the derivative of tan inverse x will be 1 over 1 plus x square. The integration of x dx will be again x square over 2. Okay, now we have to add plus c at the end. So now let's integrate the second part. So it can be written as x square over 2 tan inverse x minus, we can take 1 by 2 which is the constant and multiplied with the variable part common out of the function. So it will be like minus half integration of x square over 1 plus x square into dx plus c into dx plus c. Okay. So now we can write it like this, tan inverse x minus half. Now student, remember it, whenever the polynomial function's highest degree in the denominator and the numerator are same, you cannot integrate it directly. You have to reduce the power first by like rationalization or long-term division or addition or subtraction. You have to reduce the power first, then only you can integrate it. Okay, so what I am doing here is that I am adding 1 in the numerator and subtracting 1 simultaneously. Okay, so that the 1 and minus 1 will get cancelled out, and as it were we have added nothing in it. Okay, but we will be able to reduce the power. Okay, so now what I will do, I will divide numerator by 1 plus x square separately. 1 plus x square will be used to divide this, and then 1 plus x square will be written below 1. So this whole term can be written as x square by 2 tan inverse x minus half. So I can write it like this, 1 plus x square over 1 plus x square minus 1 over 1 plus x square. Okay, into dx, which because we have to integrate it, plus some arbitrary constant c. Okay, so integration has become x square by 2 tan inverse x minus half. So this will get cancelled out, it will become like 1 minus 1 over 1 plus x square. Okay, into dx plus c. So we can write it like this, x square by 2 tan inverse x minus half. As we know that the integration of 1 is x minus integration of 1 over 1 plus x square will be tan inverse x, because the derivative of tan inverse x was 1 over 1 plus x square. So if we do integration, the we will follow the reverse process. So this will become tan inverse x. So it will be tan inverse x plus c. So our final answer will be something like this, x square by 2 over tan inverse x minus x by 2 minus plus minus times minus plus tan inverse x over 2 plus c. So this tan inverse x and this tan inverse x can be written together. So we can write it as like this, x square plus 1 over 2 tan inverse x, we can take tan inverse x common. So there is x square, there is 1, and divide by 2 is the LCM in denominator, minus x by 2 plus c. So this will be our final answer. Okay, so this was the integration by parts. In next lecture we will be seeing some other topics of the integration. Till then, take care, bye.